Okay, here is the client code for sending 1 MB to a server. So there's two programs, one for the client, one for the server. They are both going to run on my computer, so they're on the same machine. So they're going to communicate through localhost. And basically, the server has to start first so that it's waiting for a connection request when the client attempts to connect. If that wasn't the case and the client attempted to connect and there was no server waiting, the connect attempt would fail. So here's the code. Um, so let's just look at the hints here first. You can see that I've told it that I want to use address family INET. I could have specified INET 6. It really wouldn't matter for this example. And I said that I wanted a streaming socket. I don't want a datagram socket. There are size limits to what you can send through a datagram socket, but not through a streaming socket. Okay, and so then here's the call to get address info. You can see that the node is localhost, so it's going to use the local feedback connector, loopback connector, whatever it's called. I use port 2520, so that's in the, what's the term I use, reserved range. You can use them. It's maybe not a super idea, but it works. I know I don't have any other servers using that port running on my laptop. The hints, I pass it the hints, and it's going to give me back a pointer to a linked list of addresses. So I give it the address of the server struct there. Okay. Now, here's the call to create the socket, and so the address family, I'm taking it from the results of the name lookup, and I could have just used AFINet there too if I wanted. For the socket type, again, I used it from the results. I could have just hard-coded sockstream there, and for protocol, I could put 0, but again, I'll use whatever was filled out in the results there. Okay, so I've got my socket, and now I tell it that I want to connect, and I give it the address. This is going to be the address that it looked up for localhost and port 2520. There's the length. So I'm making that connection request, and there isn't any error checking here. When you're coding this kind of thing, normally you should do error checking, but I'm trying not to clutter the code here. And here I'm just allocating a 1 MB buffer, and that's the local variable, so it's going to be on the stack. And I found I could allocate a couple meg on the stack, okay, but if I went much beyond that, then I'd overflow my stack and the program would crash. So if I want it bigger, I should malloc it and use dynamic memory allocation. So here's the call to send, and so I give it the file descriptor for the socket, pointer to the buffer, how many bytes I'm sending. You'll notice I didn't actually initialize it with any data, so it's just sending uninitialized garbage. And the flags are 0. And when it returns, it tells me how many bytes it sent. And I really should be checking to make sure that wasn't -1 and that it was equal to buff size. But I print it out, and then you can see that I'm freeing the address info and I'm closing the socket. So that is the client side. So now let's look back at the server code, which is receiving. Okay, here's the server code, and it's a little more involved. It has to do more. So first I'm creating the socket right here, and you can see I've hard-coded those values because I'm not using get address info, because I don't need to look up a host name. I am the one that's being connected to. I just need to know what port I'm binding to. This next part here you can ignore, but if you're developing server code and you're going to be frequently restarting your server, then this is useful to have. And what it tells it is not to use the usual, something like a 30-second or 60-second lockout. So when you bind to a port and your program terminates and closes that socket, usually that port cannot be reused for 30 to 60 seconds. It's a security issue, and also to make sure that you don't start up another program and get old data coming in that was meant for the old one. But if you're testing, it's kind of a nuisance, so just ignore that part. You don't really need it. Next, I give it the address that I want to bind to. And you can see I'm using sock address internet type here. That's just what it makes sense to use if you're doing internet programming. So I tell it what address family, which is internet, the host, and note here that I'm converting the port number. That's host to network short, so it's changing the byte order to match the network byte order. The network byte order is always big endian, whereas the servers that we're running in the labs and my laptop are usually small endian, so that's important. I'll talk more about that on the next video. And here I tell it which network adapter I want to use. I'm saying use any adapter, and so it'll default to probably my wireless, or actually the loopback connector in this case. So I bind, and you can see that I convert the struct to the sock adder type, because that's what that call expects. And then I listen, and if you look, you'll note that the backlog is 0. So there's a minimum backlog that the libraries will use, and you can't go under that. So by putting 0, I'm just accepting their default. And it used to be like 16. I think it's even higher now. If you want more than the default, then you need to specify, a bigger number. For this case, I know I'm only receiving one connection, so 1 or more is plenty. So 0 just uses the default. Okay, so here's the call to accept, and you'll notice that the client, there's no client address struct or size. I've set them both to null, which means I don't need to know the address of who's connecting to me. I don't want to do anything with it. And I record the new socket file descriptor, because that's when I'm going to receive. I'm going to be receiving from that socket. That's the connection to the client, not the socket that's bound listening for connections. Okay, and so here I've allocated a buffer that's 2 megabytes. Why? Just because. It doesn't have to be the same size as on the client. If you want to accept all the data from the client, it's got to be at least that big. And this I would have liked to have worked with you in class and build it up, but since we're online, I'm just going to show you the code. And so here I receive on the new sock file descriptor, and I give it the pointer to the buffer, and it's offset by the number of bytes that have been received so far. And if you look up, that's initialized to 0. Space is how much space is left in the buffer, so I don't want to overwrite the end of the buffer. So initially the space is equal to the size of the buffer, flags is 0. So I print out how many bytes were received, and if the bytes are less than or equal to 0, either the connection was closed or there was an error, and I want to finish up. So that break will get me out of the loop. Otherwise, we receive some bytes and we need to receive more. So update the number of bytes received and update the amount of space left. So you decrement that, and then you repeat. And so we could get that 1 megabyte all at once, or we could get it in 100 little pieces. And I will show you actually what it looked like when I ran it. And it's not consistent. Running on the same computer, you can get different results. But I'm going to keep going as long as I've got space left, or until I break out of it, because it returned a 0. And we're going to see that it returns 0, the client closed the connection. So then the last thing it does is it prints out how many bytes it received, and it closes both socket connections. So now let's go look at the output. Okay, So I split my terminal window, and at the top I started the server first. That's bigrecv. And then it was just sitting waiting for a connection request. So then in the other terminal there, I ran big send. And so it connected to the server. It sent a megabyte, 1,048,576 bytes, and then it closed the connection and returned. And then you can see back up at the server, first it received close to 64 kilobytes, not quite, and then it received close to 32 kilobytes, not quite, and then close to, 96 kilobytes. And that was the last chunk of data it received. Then it received 0 bytes, so the connection was closed, so it broke out of the loop, and then it printed the total, which matches what was sent. So success.